So FTC stands for First Tech Challenge, and it's a robotics competition for middle and high schoolers. A couple things before we get started. Make sure you have a mouse since that makes using Onshape just a lot easier and faster. We're also probably going to go over time a bit. You can expect maybe 1.5 hours. And again, make sure you have an education account at Onshape already created. So Kevin is now going to get us started with the agenda.
So first, I'm going to introduce you to Onshape. Then I'm going to go over sketch tools, how to create custom parts with a battery box project. And Tara will go over how to assemble a basic drivetrain. If you have any questions, please ask in the chat. We'll answer through the chat or by the end of the meeting if we have any time. So what is CAD? CAD stands for Computer Aided Design, and it's a software used to aid the design of parts in assembly and engineering. More simply said, it's basically like 3D modeling. In FTC, CAD is used to make 3D assemblies of robots and design custom parts. CAD is very beneficial for multiple reasons because it solves a lot of preventable problems, such as spacing issues or subsystems conflicting with each other. It will save time when you discover and fix problems in CAD before you build your robot. CAD is also a professional tool used in many STEM fields, so having CAD knowledge and skills will benefit your future career. And if you want to create 3D printed or machine parts, CAD will be necessary to design them. Now for what is Onshape. Onshape is a fully featured CAD package. It runs entirely in the cloud, so you don't need to download anything to get started, and it can run on any computer. It also has apps as well. Onshape also has one of the best collaboration workflows in the industry, since Onshape allows multiple people to work on the same document at the same time and allows users to follow each other and see another user's screen. You can also join an Onshape team to collaborate with others on designs. Onshape has FeatureScript, a programming language where you can write custom features. The community has created many useful feature scripts, which you can use completely for free, so which helps you easily model complex features such as gears. And if you're just starting out with CAD or you don't have powerful special computers, Onshape is a very good starting place for you. So I'll be going over some mouse controls in Onshape. When you're in a document in Onshape, to rotate your view, you can click your right mouse button and drag it around to rotate. To pan in Onshape, you can press the Control key, then drag your right mouse button to move around. Or you could just press your middle mouse button and drag it. Finally, to zoom in and out, you can scroll your mouse wheel in and out. This is what Onshape's homepage should look like. If you don't have an education account and you're not logged in, now is the time to do so. So this is what it looks like when you're logged in. You can always press the Onshape icon in the top left corner to go back to your home page. You can join a team to collaborate with others in your FTC team. Most importantly, to create a new document, you need to press the blue Create button. Then you'll find the document. You click that to create a new document. I'll be doing that right now.
Feel free, feel free to follow along.
Yeah, feel free to follow along on your own computer. So now, first we'll be creating a sketch, which is the usual step for creating 3D parts, where you first create a sketch, then use the tools Onshape has to turn that sketch into a 3D part or feature. Create a sketch by clicking the leftmost tool, which has the pen and pencil icon. Then Onshape will ask you for a sketch plane. So I'll press the top sketch plane for now. You can press the top face on your view cube. This way, you'll be looking directly at the top plane. Now I want to introduce you to our battery box project. To show how Onshape tools can be used in practical FTC scenarios, I'll be CADing a battery box for our FTC battery. Its dimensions are 90.5 millimeters by 113.5 millimeters. For our first step, we'll be creating a corner rectangle, which is going to be the base of our battery box. Select the corner rectangle tool. Make sure that you're selecting the corner rectangle tool, not the other tools. Then click two places in the top plane to determine the corners of your rectangle. I would like to click on the first point on the origin. Wait,
We don't know how to go to your view from the 3D view. Can you show us again?
oh, okay, no problem. So here's the 3D view. Can you see my mouse cursor?
Yeah.
Yes.
Yes, so I'm hovering over the top face of the view cube, so you can press it.
Use
And
Enter key or just press the left
no,
key.
my mouse is hovering over the top face of the view cube, and you can just left click.
Oh.
Thank you.
Does that solve your problem? Also, I believe Tara posted our Google Slides link, and our Google Slides has detailed instructions. So hopefully, if you have some questions, you can refer to this. So I'll give everyone a few seconds to be orienting at this position. Okay, so now we're going to create the corner rectangle. You can see the rectangle icon. Press the down arrow, and now you can see there's 3 rectangle tools, but we only want to have the corner rectangle tool. Now we can choose 2 points in our plane to determine the corners of our rectangle. I'll choose the first point as my origin, and the second point somewhere in the first quadrant. I'll type in 90.5 for the first dimension and 113.5 for the second dimension. This is the dimensions of our battery. However, we want our battery box to be slightly larger than our battery, so it has room to fit in. Therefore, we want to increase our side length by 4 millimeters. You don't have to do the math here, since you can just do 90.5 plus 4, and Onshape will automatically dimension that for you. You can repeat this here.
Kevin, somebody said
Yes?
they don't have the tool for the like on the top right.
Wait,
The
you
first
don't
thing we
have the
need to,
toolbar?
yeah, so the first thing we need to do is create our 2D thing. We want to draw some shapes. So
Yes.
that's done in the sketch tool first. So at the
If you-
top left, you'll see a sketch button. And when you click sketch, you can then select the top plane. So you select where you want to start drawing.
And then I
And then
think,
you'll have all the shapes.
yeah, I think you can see the corner rectangle. Okay, I'll just delete that sketch. So
But
I'll give,
if you don't see the top right, what tool they don't see? Is that they don't see the rectangle tool? Sean, you mentioned you cannot see the tool. What tool you don't have it?
The corner rectangle tool.
Oh,
can you see like the line, circle, and these icons?
No, my first 2 icons are the same as yours, like that box inside a box and then like the donut shape. But then
Oh, so
after,
do you see this?
yeah.
they are not in the
Okay.
sketch.
You need to, have you created a sketch yet?
Yeah.
Double click the
You need
sketch.
to double click on your sketch to enter the sketch.
Oh,
Does
I
that
got it.
solve?
Thank you.
Okay, now you can see the corner rectangle tool. I'll give everyone a few seconds to finish this step.
How do I change the side lengths? Like, can I type in the side lengths?
You can uh you can double click on these numbers and then you can type in whatever you want.
There's also the dimension tool on the top,
Yes.
which is the letter D for shortcut.
Yeah, this is the dimension tool. And you can double click on the numbers you see if you want to dimension it.
Somebody might be in the inch, not in mm. Tian, can you tell them how to actually change that? Make things easier.
If your units are not millimeters, you can always type millimeters after the number.
There is another way. Go to the menu, top left, the menu.
Okay.
No,
Oh, this.
not on the
Yeah.
right, this one. And there is a workspace unit, the number 5, yes. And default, yeah, somebody, this might be inch. You can change it to millimeter.
You can change it to millimeters this way.
Yeah.
Okay. Does everyone have this step completed? Okay, I'll move on.
Substance still ask, how did you add the rectangle? Yanshan,
Okay.
did you figure out how to do that?
I figured it out.
Okay, cool.
Okay. Does anyone still have any questions? Okay. I will continue on my next step. So we have the base of our battery box, but we also want the walls of our battery box. If you can see here, our battery box has walls and this is because we have an outer frame that we extruded up into 3D. So we want to create an outer frame which will represent the walls of our battery box. To do this, we need to select the offset tool. It will be over here. You can also press O. Then you can select the 4 sides of your rectangle. Then drag the arrow out to create the outer frame. Double click on the dimension, enter 4, and now you have created the outer frame of the battery box, which is 4 millimeters thick. I'll give everyone a few seconds to finish this step. Okay, does anyone have any questions before I move on?
Wait, how do I select the 4 corners?
Okay, I can redo this. So, you selected the offset tool. You can select the 4 sides of the rectangle. You'll know that you're selecting it when you see that the side turned yellow.
Yeah, basically using left mouse, click on it when you select it.
Then you can drag. This arrow is pointing inward, making an inner frame, but we don't want an inner frame, we want an outer frame. We can drag the arrow out. Then we can scroll in, double click on the dimension. We can type in 4, press enter, and then this will create the outer frame wall of your battery box, which is 4 millimeters thick. Does that help? Okay. Um, does anyone have any other questions? Okay, I'll move on. So next, we select the center point circle tool because we want to add some screw holes to our battery box. As you can see over here. So these screw holes will screws will be in the screw holes, which will secure this to our robot. We can select the center point circle tool. Make sure that you're selecting the right tool and not some other circle tool. You can click on the top plane to determine the center of your circle. You can drag out with your mouse and click again to determine the circle. You can type in 4.2 millimeters for the diameter of the circle and press enter. We can press the escape key to exit this tool. Then we want to dimension the location of the circle, as it can be anywhere in this box. So we use the dimension tool. You can also press D. We click the center of the circle and the side wall of our battery box and drag down with our mouse. We can click to set the dimension holder in place and type in 8 millimeters for the distance between the center of the circle and this rectangle. We can repeat this for the other side of the rectangle. Does anyone have any questions? Okay. Next, we want to duplicate this. Yeah, did you have a question? I think you're echoing a bit and I can't hear you clearly. Could you say that again?
Or you could type your question in the chat.
Yeah, okay. I like when I'm sharing my screen, I can't really see the chat, but
Okay.
I think other members from our team will answer them.
Somebody asked, how do you change the diameter of the circle?
So, when you create your circle, you can double click on the dimension. Like right now it says 4.2 and the arrow is pointing at the circle. So we know the diameter of the circle is 4.2. You can double click this number and type in whatever change the number if needed. Right now I can leave it at 4.2.
It is also possible, like when you initially put the circle there, you did not put any dimension there. Then you can use in the dimension tool later to add a dimension for it. For example, yeah, Kevin is demonstrated. Using dimension tool, select that circle, and then you can make the diameter of it.
Yeah. Okay, does anyone else have questions?
Questions, you can either say it out loud if you need a demo, or you can ask in the chat. I am working really hard on getting it all out.
Okay, thanks. Okay, I'll just wait an extra few seconds.
How do I move?
What? Wait, what?
Sorry, say that again.
The question is, how do you, he wants to move the circle.
How
Oh,
do I move
okay.
the circle?
Are you saying like, wait, what do you mean? Like,
Like when after you put the circle there, how do you move it into like the correct position?
oh, you don't need to move it to the correct position. So right now, after I created my circle, it can move around, right? I can drag it. So I can use the dimension tool that I'm hovering over my mouse here. I can click it. I can then click the center of the circle and then click the side of the rectangle. Then Onshape will tell me the distance between the point, this point, and the side. I can drag out this dimension, then click. Then Onshape will let me change the distance between the point and the line. And I want it to be 8. I can repeat this step for the other side of the rectangle. Does that clear it up for you?
Yeah, thank you.
Okay. Now I'll move on to my next step. We want to duplicate this screw hole into 4 screw holes so we can properly secure this battery box to the drivetrain, since just one screw cannot be enough. So we use the linear pattern tool. You might not see it at first, but you may need to click the down arrow next to either 3 of these icons, then click the linear pattern tool. It's also right next to this page icon. Then once you have selected the linear pattern tool, you can recognize it by the 4 squares in a row. You can click the circle, and now you see Onshape is making a bunch of circles for you. Drag the arrow down so these circles appear within the battery box. Since we only need 4 screw holes, so we can change this 3x into 2. So now we have 2 times 2 equals 4 screw holes. I can change the distance between these screw holes. Make sure that if you type in like a positive number such as 96, these circles may fly out of the battery box. So if that happens, you might need to negate the number. I'll type in negative 96 and 80 for the distances between my 4 holes. Then I can left click to conclude the tool. Now I have 4 screw holes. Does anyone have any questions before I move on?
I don't have the arrow on the bottom, so I can't put any other holes.
Okay, I'll undo my step. So have you selected the linear pattern tool
Yes,
and you selected the hole?
yes.
Okay. You might need to zoom up to find the arrows.
Oh,
Okay. Zooming out helps because the arrow might initially be pointing at another direction. So we can drag the arrow down again. Then we only need 4 screw holes, so we change the 3 to 2. So now we have 4, as you can see here. And the distances between the screw holes depend on your robot, but I'll just type in negative 96 and 80 for now. Then I can left click to conclude the tool, and now I have the 4 screw holes. Does anyone else have questions? Okay, I'll move on. Now it's good to rename your sketches so you know what this thing that you drew is all about. So I'm gonna rename this to bottom because this is the bottom of our battery box. Notice that when I press the green check mark, I exit out of the sketch. And now I see this faint gray outline of what I just made. Now, when I'm looking at this in 3D view, I see these annoying planes that Onshape drew. So I'm going to hover over these planes and I can see the eye icon. Then I can hide them. Now we are ready to extrude our battery box. Extrude kind of means pulling this 2D sketch up into a 3D feature or part. We can select the the second to leftmost tool, which is right next to the sketch tool. It is called extrude. Then we can select the base of our battery box. And you see Onshape automatically kind of pulls up the face, making it into a 3D solid. I can change the depth to 4 millimeters since I don't need the base of the battery box to be so high. I can rename this extrude to base. And then I can press the green check mark. Does anyone have any questions?
How thick was it again?
I made this 4 millimeters. Does anyone have any other questions before I move on? Okay, I will move on to my next step.
I accidentally duplicated part of the outline. How do I delete that?
Wait,
Can you share your screen? And I'll take a look at it. It shouldn't disrupt the main screen.
Maybe Control Z is the best way to just revert whatever you have done.
yeah. Does everyone else, does anyone else have any problems? Okay, I will move on to
like,
my next. Wait,
I have like an extra 3 lines here.
wait, I can't really see your screen right
Can
now.
you open the sketch?
Okay, I'll just
Wait,
let
am I
Lisa
not
know.
sharing?
You are sharing. I'm taking a look at it.
Am I not sharing?
You are sharing. Can you close the extrude and double click the sketch on the very left?
Yeah.
Okay, there's what happened here? I'll create a breakout room and then we can fix it there.
Okay.
Or maybe fix that later. Let's continue the class so he doesn't miss the class.
Okay, so I will continue right now. So you may notice that after we extruded this, we can't find the sketch we created anymore. That's because we can see the bottom sketch we created is kind of like faded out. It's gray. So we can hover over this sketch. Then we can click the eye icon. And now we can see our beautiful sketch again. This time we want to extrude out the walls of our battery box. So we press the extrude tool again. We can press this and it will extrude this for you. We want the depth to be 43 millimeters. As you can see, Onshape automatically says that this is adding on to the original part we created, which is what we want. So we can press the green check mark. Actually, wait, we need to rename this. So we can rename this to wall. Then we can press the green check mark to conclude our extrude. I'll leave this up here and wait a few seconds so everyone can catch up. Does anyone else have questions? Okay, I will press the green check mark and move on to my next step. Now we may want to add some extra mounting holes to our battery box because we might want to mount some other part in FTC to this battery box. So we could create some extra holes on the side of this battery box just in case we need something to be there. We will be following Go Build a Quad Block Mount pattern, where 4 holes are revolving around the center of the mount and they're 16 millimeters apart. So to carve out some holes, we need to create a sketch on the face, create the holes, then we can extrude those holes, which will be and we can select an option to be cutting through the walls. So now I will create a new sketch using the leftmost tool. Then I'll select the wider face. This face is this face in the battery box is narrower than this face, so I'm going to choose this face to put my sketch on. I can press the right face of the view cube to be looking directly at my sketch. Make sure that you could create a sketch here, but I'm going to create a sketch on the right plane. So when I press the right face on the view cube, I'm looking directly at my sketch. Now I'll create a circle, which will be one of our screw holes. I'll make it 4.2 millimeters in diameter. I will go up to my toolbar and press the point tool, and I'll click anywhere I want to put my point. I can press escape key. I can press the escape key to escape my tool. Now we want this circle, the center of this circle, to be horizontal to the center of our quad block mount. As you can see in this image, this circle is horizontally aligned to the center of our quad block mount. To do this, we use the horizontal constraint. So our circle, the line between the center of our circle and our point is horizontal. I'll wait a few seconds for everyone to finish this step. Okay, does anyone have any questions? Okay, I'll move on to the next step. So we want to duplicate the screw hole into 4 screw holes revolving around the center of our quad block mount. We can use the circular pattern tool. It's right next to this page icon. You can press the down arrow and find the circular pattern tool. You can click on the circle. So Onshape knows this is the circle you are duplicating. You should probably scroll out, and then you'll see that these circles seem to be revolving around a point, which is boxed in gray. We can drag this point around. So this point will be coincident with the point we just created. You'll know this happens when we see this coincident constraint icon. It has like 2 lines intersecting at a point. Since I want 4 screw holes, I can change the 3x to 4. I can drag this handle around a bit to see that the this circle makes a 270-degree angle with that circle, which is what we want. Since we want the circles to be making adjacent circles to be making a 90-degree angle. Finally, we can left click to conclude this tool. Now we have 4 screw holes revolving around the center. Does anyone have any questions?
One question is, how did you get a horizontal constraint? Can you show him again?
Okay, I can show you again. So after we create the center circle, and then we create a point, like somewhere here, press the escape key. You can select the horizontal constraint. You can also press H to get it. And on the toolbar, it just looks like a horizontal line. You can press the center of your circle, then you can press the point. And automatically, Onshape makes the line connecting the 2 points you selected horizontal.
Kevin, did you just, this is another Kevin, did you just not see that horizontal constraint?
If you can't see it, I believe that you can also press H on your keyboard to call that tool.
Yeah, sometimes the tool, not all the tools will show up. Like they might be because maybe your screen displays like the font is too big, so it only show some tools. For example, here, so you have to click this drop down in order to see them, or you make the font smaller so all of them can show
Yeah.
immediately.
Okay.
Yeah, you can remove that, Kevin.
Yeah, I will remove the circle.
Select them and delete it.
Does anyone else have any questions? Okay, I will move on to my next step. So we can drag all of this around, which is not what we want. As I've stated before, these screw holes are 16 millimeters apart. Therefore, we can dimension these screw holes to be 16 millimeters apart. Make sure you're not doing this. This is just defined as the horizontal distance between these screw holes. You want to make it so that just the distance between these screw holes, it will make a diagonal. The distance between these screw holes are 16 millimeters. Then I will dimension this point to be 21.5 millimeters away from the bottom of the battery box. And I'll dimension the point to be 24 millimeters away from this edge of the battery box. Now we have made our screw holes with the correct dimensions. Does anyone have any questions? Okay. I will move on to my next step. So it would be great if we could have all of these holes, but to the right of our battery box, on our battery box side. We could we could definitely recreate them, but since I'm lazy, I'm going to use the mirror tool to mirror them over a center line to the right side of our battery box. Select the uh, leftmost sketch tool, which should be a line. Then select this tool. It's called the construction line tool and it has two lines, two vertical lines. Now I'll hover over this top edge of the battery box until I see this yellow square. This means that the point I'm selecting is the midpoint of the line. I'll click. Now I'll drag down to the bottom. And once again, I see that yellow square, so I know that this line I'm creating has its endpoints the midpoint of the sides of the battery. Then notice that Onshape lets me create a new line by when I'm dragging around the second endpoint. I don't want to, so I am going to press the escape key to escape this tool. Now I'm ready to use the mirror feature, the mirror tool. Press this icon, which has a dotted line and two reflected sketches. First, it will ask me to select a mirror line. And now it will ask me to select the entities to be mirrored. I'll select my 4 circles. And now you see that one by one, these 4 circles are being reflected over this line of symmetry. I press escape to escape this tool, and now we have these 4 holes on the right side of our battery box. Finally, we need to make a slot for this battery mount Velcro thing to go into the battery box and secure the battery. Oh, I also forgot to ask, does anyone have any questions? Okay, now I'll move on. So I want this thing to go through a slot in this battery box so it can wrap around the battery and secure it. So the battery won't be jumping around in the battery box every time our robot collides with something. To do this, I need to make a line and I can use the slot tool to turn that into a slot. First, we can select the line tool and click the first endpoint and find the second endpoint. Notice that you need this yellow blue line. This means that this line we're creating is horizontal. I'll type in 32 millimeters for the distance of this line, then press enter. I press the escape key to prevent me from creating another line. I can then use the slot tool to turn this line into a slot. It may be hidden by the offset tool, so you need to press the down arrow and find the slot tool. It looks like a slot. After selecting the slot tool, I can go ahead and select this line. I can make the diameter of this slot, and I can leave the diameter of this slot at 2.5 millimeters. Then I'll left click to conclude this tool. Does anyone have any questions?
There was a question previously. How did you create the mirror line?
What?
How did you create the mirror line?
Okay, so I can delete it. Yeah, I can redo this. So you select the line tool, then you can hover over the top of this battery box. And once you see this yellow square, this means the endpoint of this line will be the midpoint of the yellow line I was selecting. Then you drag down until you see that yellow square again. So then you know that this line is bisecting, is cutting this battery box side in half. It is important to make this line a construction line. Therefore, because construction lines are basically used to help you construct something, but when you're extruding it or doing something else with it in 3D, this line will not be considered when you're extruding it. Now we use the mirror tool, which looks like this. We can select our mirror line, then select our 4 holes. Oh, I accidentally selected the line, but I'll delete it later. And then I can press the escape key to conclude this tool, and I need to delete this line because I accidentally selected it. Does that help? Okay, now I'll move on. So we want this slot to be centered in our battery box. So we can use the symmetric constraint. It looks like this, some like hourglass. After you select the symmetric constraint, you first select the line of symmetry you want to have. Then you can select the endpoints of our line. And now you see that this slot is centered in our battery box. You can see it can still move up and down, so we'll just dimension this to be 20 millimeters away from the bottom. Finally, we're done with this sketch, so we can rename this to side. Before I move on, does anyone else have questions? Okay, I will move on. You can conclude the sketch by pressing the green check mark. Now we are ready to extrude these holes to the other, so we can cut out them. We can press the extrude tool again. Then we need to make sure that we change this to remove because we're removing some parts of the battery box. Now we select our holes and slots we created. Now we also want to cut this all the way through to the other side. We don't really want to extrude this blindly because it could easily mess up something else. So we want to extrude up to the next the opposite face on our battery. You can select this face. And now it will automatically extrude cut these holes and slots to the other side of the battery box. We can rename this to holes. And congratulations, you are finished with your battery box. Does anyone have any questions?
We can let people to finish this.
Okay.
Can you explain what each of the holes are for?
They're not for anything specifically. They're just here just in case if we want to mount something to our battery box, for any reason, we can have holes to mount it. We are following the Go Build a quad block mounting pattern. So yeah, so that's why we're creating these holes in this shape. They're just there so we can mount something on our battery box if we have the need to.
Kevin said he did it, but it did not remove the hole from the other side.
Oh,
Can you open that exclusion? Just show what's the exact settings there.
okay. This is what I did. The order I did it is that I first selected remove, then I selected all of these sketches. Then I selected up to face. I then selected the opposite face. You need to make sure you're selecting this face because if you select this face, it won't really cut through the walls and it won't make holes on the other side.
Also, make sure when you select the other face, on that menu, it is focused on the up to face, that particular selection there. No, the next one, like this one. Like if it's not focused on this, but you select that, then you probably did something. It will not work correctly.
Yeah, you shouldn't be selecting a line when you're selecting the face.
No, I'm also saying that Kevin, can you delete that under the up to face, that selection? No, next one, the next one.
Oh,
next.
this one. Yeah, I can
press that
rename
X, and then when this is selected, go to select the other face. Now you select the other face. Yeah. And then green checkbox.
Does this
Okay.
help answer your question?
Do you want help there? The other Kevin said it still does not work. But this is our last thing for the battery box. Etienne?
Yes.
I'm on it.
Oh. Okay.
Okay.
Oh, you're asking him to join our break room so that you can show him. Okay, cool.
Okay.
Actually, Kevin, before we end this, can you also show something quickly? Like, because I think that feature is also super useful. We use it a lot when we 3D design something. The fillet. Can you show how
okay.
to fillet? Like
I can show the fillet tool. The
Yeah.
fillet tool is this You can press Shift F to activate it, or you could press this icon. It's kind of like that. Yeah. Then you can, you're selecting the edge, and then you can select an edge to fill it. Right now, it's not working because there's obvious problems. So let's
Already
say
too big.
I made my radius smaller, and now I'm rounding out this battery box hole. So now our battery box looks a lot cooler, and the sharp edge is removed, so you can't hurt yourself with the battery box.
Yeah,
Okay.
usually we do that scenes for all of them, like all the 4 edges. That's very common actually.
Yeah, we usually fill like 4 edges. Yeah. Okay. Do we have time to go over constraints, or should I
I don't
just
think
let
that's
Tara?
very important. We already significantly run over time. One last thing, people will be interested to know. Okay, now you design this thing, right? And this is a 3D design. You are likely you want to 3D print it, right? How did you get from here to actually go to 3D print? What will be the next step in Onshape?
Oh, you can export the file. Oh, I forgot to prepare that.
No. It's very simple. Right click the part on the top left, left. Yeah,
Yeah.
the part 1. Yeah, right click it, export it. And select the format STL. Right, the format is, yeah, if it's not STL, make sure you select STL. And then you can name it. You get STL file. Somebody, yeah, you can bring it to a 3D printer machine, or like go to online 3D print service. And yeah, that will be the file you are 3D printer.
Okay. That's the end of my presentation. I'll let Tara do the assembling.
Yeah, wait, is Kevin back?
Kevin should be back.
Yeah. Yeah,
Oh,
now
where
I
are
can
you?
see
Okay.
like the chat
And
and
the
stuff.
break room, yeah, I think it's back, right?
Yeah, I closed the breakout rooms.
Okay.
Wait, the team, can you? Okay. Okay. So now we're gonna learn how to assemble. So that's basically just like taking CADed parts and pre-downloaded parts and just putting it all together to actually make something. So we're gonna assemble a drivetrain using downloaded Go Builder and Rev parts. So if you don't know what a drivetrain is, it's essentially the base.
Sorry.
It's essentially the base of a robot, and it typically includes the wheels and the motors. So on the right here is the drivetrain that we're gonna make, and that's also the one that our team is currently using right now for our robot in FTC. And this drivetrain, other than the wheels and the motors, it also has 2 hubs, the expansion hub and the control hub. You can see how like under these light blue plates, there's these 2 boxy things, those are the hubs. And these are the brain of the robot, so they're what controls it. So most robots are gonna have 2 hubs, and we'll probably have them on the sidewalls or somewhere else. But this robot is unique in that it actually hides the hubs under the rest of the robot, as you can see. So the first thing that we're gonna do is we're gonna download some parts from GoBuilder and Rev. There are links to the parts in the Google Slides. But okay, so we're gonna go first to gobuilder.com. And we're just gonna, the first thing we want is a drivetrain kit. So we're gonna pick this chassis and this strafer. So now you're gonna scroll down until you find the step file, and then we're just gonna download that. So since it's zipped, we have to extract it. And then the next thing we need is a plate. So we're gonna go to structure and then pattern plates. And then the 1 times 9 hole 1. So you can also just use the search bar, or again, you can use those links in the Google Slides. But again, we're gonna find the step file and then download it. And then next is a channel. So channel, low side U channel, and then the 9 hole 1. And we're gonna download the step file. And then lastly from GoBuilder, we need some mounts. So we're gonna go to mounts and then dual block and the 1-5 mount. Okay, so now we're gonna move on to Rev, and then we're gonna get our hubs from revrobotics.com. And I'm just gonna use the search bar and find the control hub. Here's the step file. And then we're also gonna find the expansion hub. And download the step file. Okay, so now that we have all our parts downloaded, we're gonna go to Onshape and then import these files so we can assemble them. So you should probably make a folder. And then we're gonna go to create and then press import files. And then import all the files that we just downloaded. So import to a single document and then press import. So here you can see that it's uploading. And this is gonna take a while. So you guys should also follow along on your own computers.
Wait, how do I import?
Yeah, so do you see the create button? You press create and then import files.
Okay.
So we need to wait until it says translation completed. So like here you can see, even after it's uploaded, it also needs to like fully import. So we need to wait until it says translation completed.
There are 6 files, right? Yeah.
Yeah, 6. Yeah, this last one definitely takes a while to import. You can see how if you go in before it's fully imported, it's just going to show this.
Is anyone having issues?
Letian, did you make a big zip file for all step files?
Yes.
Yeah, it's in the chat if anyone wants it.
When I'm importing it, it's like asking me if I should import to a single document, or like split to multiple documents.
Yeah, you can import to a single document.
Use the single document one.
Yeah, the default setting is working. Just do the default setting. Don't need to change anything.
Okay, this is taking a really long time. So to import, you just go to create on the top left and you just press create. And then in the drop down, there's import files. And you just select the files that we downloaded. Yeah, remember to unzip the files.
Yes, sometimes that translate takes really long time. It's still uploading, not translated yet.
Here's the drive train that we're gonna make.
Maybe too many people try to import at the same time, so the server is so busy. Maybe. Sometimes takes several minutes.
Yeah. Okay. So now that it's imported, we can actually see all the stuff. So what we want to do is go to the file that had the original chassis kit that we downloaded. So that's this one. Because we're just going to make a few adjustments to this drivetrain that we got from GoBuilder. Okay. So what we're going to do is we're going to get rid of these channels here. These are the crossbars and we don't want them because we want to replace them with, as you can see here, we have the low side U channels that we put on the side, on the very edges instead. So we're just gonna select crossbar here and we're just gonna delete it. And before we get started with doing anything, we want to group each of these sides together just so it's a lot easier and it's going to treat all of this stuff as one component instead of having to deal with individual parts. So I'm going to group each of those sides. So the first thing we want to do is add these low side view channels. These are the dark blue things. We're going to add those. So you're going to go to insert here, insert parts and assemblies, and then other documents. And then here you can see all your files, and I'm going to choose the folders. I'm going to choose the folder with all the parts we downloaded. And then this one is the low side U channel, and I'm just going to insert this. And what we also need is we need our mounts that we downloaded. That's this. We need it to actually like mount the low side U channel onto these sides. So for assembling stuff, the tool we're going to use is fastened mate. So that's this cylinder looking thing. and it essentially just locks two parts together. So the first thing we want to do is lock this mount to this side. So notice how on this mount, there's one side that kind of protrudes more than the other. Sorry, is someone talking? Okay, so we want this side that protrudes more to be facing outward. So it should be facing this way. So after clicking fasten mate, we're gonna zoom in and select this screw hole. And then we're also gonna select a hole on this side. Let's see. We're gonna select this hole. And then it's facing the wrong direction right now because we want it to be facing kind of vertically this way alongside the edge. So you can just go to reorient secondary axis and then turn it around. And then we're gonna do the exact same thing on the other side. Does anyone have any questions? Yeah, I'll give a bit of time for everyone to get caught up and reach this step. Make sure the side that protrudes more is facing the edge.
Still importing.
How long does it take to import? I think normally it should take, it doesn't take this much time normally, so it just,
It is possible that because this is a pretty big file and so many people try to import at the same time.
Yeah.
Take a while. So
and
yeah.
I'll wait a bit for everyone to actually get that imported.
Mhm.
And then I can just go over the steps again, since it seems like a lot of people don't have the file open yet. So this is the original drivetrain, and we're gonna adjust it a bit. So we want to delete these crossbars because we want to replace them with the mini ones, and we also want to put them at the very edges instead. So we can just select crossbar and delete both of these. And then we have to group each of these sides just so it's a lot easier to interact with. Otherwise, we're going to be dragging like small individual parts around. And then we want to insert our, so we want to mount our mini channel to these sides. So in order to do that, we need these mounts that we downloaded. So I inserted both of these. And then I'm going to take fastened mate and then select this screw hole. And then fasten it to this one. So again, we want the protruding side of the mount to be facing outward. Yeah, if it just shows like a pop-up that's like update and then download, that means it hasn't been fully imported yet. So you're gonna have to wait until it says like, hold on.
Wait, I can't delete my crowbar. It only lets me hide it.
Wait, hold on. Let me open this. When you can you see this like list of all the parts?
Yeah, I can see that.
Yeah. If you right click on it, does it show delete at the bottom?
No, it does not show delete.
Wait. Can you try just using the delete button on your keyboard?
Um,
I click on this. Delete it, right?
no, I just don't. The delete button works. Okay.
Okay.
Thank you.
Evan has an issue.
Okay, wait, I think so. When you import it, there's like a little home button on the bottom left. If you go look at the
Very
bottom,
left.
like
Very
it
left.
doesn't show it on my computer, but like press the home button and then it should show all of this.
Yeah, that's true. Sometimes they may not immediately show this card, like the card view. So you need
No,
to
but like,
home button.
oh, sorry. But then like, how do you import the orange piece? Because I already imported it, but like, how do I bring it into this
So
file?
can you see insert on the list of tools? You can press insert and
Oh,
then there's other documents, and then you're gonna find your folder where you put all the where you imported all the parts, and then you should be able to just select the mount.
okay. Thank you.
So I'm gonna move on, and then we're just gonna do the same thing we did here on the other side. So again, we're gonna mount this using fasten mate, or we're gonna like lock the mount to the channel here. So it's on the wrong side. You can just flip primary axis here and press this, and then it's gonna flip to the right side. So now we have both our mounts and we can attach our low side U channel to these mounts. And this is also what you would do when you're assembling a real robot. Like you would have mounts and then you would attach your channel to those mounts. Although you would also need screws. Okay, so again, we're going to use fasten mate. And we want the flat surface here on this side to be facing outward. So, yeah. And then select screw hole on here. Okay, I'll stop a bit here and wait for everyone to get caught up. Does anyone have any questions so far? Oh. Okay. Then I'll wait a bit more. Wait, Kevin, do you have this file open yet? Okay.
Downloading or importing? And Kevin, without
I'm
the
trying to-
episode, sorry.
I am trying to orient it, but I can't. I'm clicking on the orient, but then what do I do?
So you mean when you're with the fastened mate, right?
Yeah, I'm talking about the small pieces.
Yeah. So is this like what you're looking at? These orient buttons?
Yeah.
So when you press this, does it not turn the piece?
No. Not.
Wait, you're talking about these mounts, right?
Yeah, I'm talking about the mounts.
And you're pressing this button, reorient secondary axis.
Yes.
Okay, wait, can you see, like, you can see the mount and it's just not moving?
Yeah, I can see it.
Okay, I think that is weird. Wait, Letian, can you maybe go into a breakout room?
Okay.
Okay. So just join room 1 if you need help on something.
Kevin, when you say the main file, which file is that? Are you talking about the one Letian sent? Hold on. So right now we're using 1121, which is the mini, the low side channel. So yeah, this is a channel. It has like these walls. Okay. I think I'll wait for Letian to get back and then we'll move on, since we've been here for a while.
Did everybody finish the step, like having any other issues? Or what's the status of everybody else?
Kevin, are you still having trouble unzipping the file? You can't unzip you can't extract multiple zipped files at the same time. You have to do them one by one, I think.
They're in
As far as-
breakdown, so he cannot hear.
Oh, okay.
Do you want to continue? Just assemble the other side, right?
Yeah.
Somebody said they don't have insert button. Melissa.
I think you might be in Part Studio. Can you make sure you're in Assembly and you're on this page?
Melissa, did you even see the main, like the drivetrain?
I don't think the part color really matters. I'm actually not sure if you can change the color. Does anyone know if you can? I think it's just with step files.
You can assign the materials like to particular parts, and or in assembly, like on the left side, you can right click assign a materials, and the materials you can create materials assign color. But that's not the main content we are going to talk today. It's mostly for rendering. That's more like decoration purpose.
Yeah. Okay. I'm gonna move on now. We're just gonna fasten for low side U channel to this upper mount. So again, I'm gonna use fastened mate and then choose this screw hole. And I'm gonna mate it here. And then press check and it automatically brings the upper side closer. And then we're just gonna do all of this on the upper side now. So insert the mount. And we're gonna fasten it to the sides. Yeah, and again, make sure the protruding side is facing outward. It's facing the edge. Okay, so we have both of these mounts, and then again, we're gonna insert the 1121 piece, which is for low side U channel. And just like the first one, we want the flat surface to be facing the outside. And then since it's facing the wrong direction right now, we can just flip the primary axis. And then there. So I'll wait a few seconds for everyone to reach this step. And if you have any questions, then now is the time to ask.
Yeah, right now, technically, this is a drivetrain that can already work.
Yeah, we just want to add the hubs under it but this is already a working drivetrain, yeah.
When you build the real robot, it will be very similar to this. Like, although you're not touching the real, this will be very similar. Use these mounts and the channels, and you will add screws for sure. But that's how you build a real robot.
Yeah. And then the next step is adding these plates and these hubs. So again, we go to insert. And then this time we're going to pick 1123, which is for plate. And we also need mounts in order to actually attach the plate to the robot. So we're going to insert those mounts as well. And then just like earlier, we want the protruding side to face outward. So we're going to grab fasten mate. And then, so I think let's place the mount here along these 5 holes. So, okay, I will fasten it to this hole. And then I'll do the same on the other side. Yeah, so we want it attached along these holes. And then just flip it if it's facing the wrong way. And then, okay, perfect. So now what we're gonna do is attach this plate to the mounts, just like we did with the channel. So I'm gonna use fasten mate again. And I'm gonna fasten it to this hole. Okay. So now what we want to do is attach our hubs to this plate. So I'm going to insert, and then I'm going to pick these two, which are our hubs. Okay. So notice how this hub has way more, these are USB ports. Notice how it has way more ports than this hub. So that means this is the control hub, since it usually has more USB ports, and this is the expansion hub. So we want these ports to be, these USB ports to be facing the outside here, just so it's easier to access. Make sure you flip the robot around. So this is the top and this is the bottom, and we're going to attach them from the bottom. Okay, so we're just going to use fastened mate and then attach these. Okay, I'm actually going to pick this hole so that I can align it with the middle. So I want the hub to be, since this is the middle, I want it to be just slightly offset from the middle. So I'm going to pick this hole. And then press check. Yeah, so notice how these USB ports are facing the outside, since it would be really hard to access if it was in the middle or facing the middle. Okay, wait. I just did something wrong. So make sure you group these hubs first, because notice how I actually brought over one part and then everything else just stayed here. So we want to group it all together. So I can just select, select this and then press group.
I'm back.
Okay, yeah. For Kevin, I think all we did is, so we added another channel on the other side. We just did the exact same thing as this side. And then we also attached this plate. So I can show that, since we're going to attach another plate, I'll show how to do that when we get there. So right now we're just mounting the hubs. So I inserted these hubs and then I grouped them all together so we aren't just dragging around individual parts. We're actually moving the entire hub. Okay. Yeah. So I'm going to use fasten mate to fasten our hub to this plate. Just like that. And then I'm going to do the same for our other hub. Okay, so notice how I chose the wrong hole, so it did not orient correctly. Let's see. Actually, okay, yeah. It should be this hole. And then we're just gonna lock that together with this plate. Okay, perfect. And now the last step is just adding another plate here so that these hubs aren't just floating in the air. So again, I'm gonna insert this plate. And then I'm gonna also insert these mounts. Again, you want the protruding side of the mount to be facing outside. Okay, so now that we already added these hubs, we know where we should put the plate. It looks like the mount, I mean, we know where we should put the mounts in the plate. So it looks like the mount should be here, since that's where these holes are. And we're going to do the same thing for the other side. And let's see. Okay, perfect. So we're almost done, and all we have to do is just fasten this plate to these mounts. Okay. And that's it. So we just, wait. Yeah, we just made a drivetrain. Okay. Does anyone have any questions?
Is anybody blocked by anything?
This is, I think we're probably gonna upload this on YouTube, so you can always go back and watch it over again if there's anything you missed.
Where will you where on YouTube?
Oh, we're gonna get to that. Wait. Pretend.
Oh yeah, and as a quick plug, we'll also be hosting a simulator FTC programming session on Monday. If you guys are interested in that, there's a link on the bottom left there. No programming experience needed, and we'll be working with the simulator.
The YouTube, I just sent out the team's YouTube channel, the link there. That we'll upload this video to there as well.
Yeah, thank you everyone for coming. If you have any further questions, you can reach out to us. This is our email, Insta, and our YouTube channel.
Cool.
I think we might stick around here if anyone has any more questions so we can answer them, but feel free to leave. Thank you.
Thank you.
Thank you.